Sometimes the tools we own aren't exactly the tools we want or that we need, but we don't always have to just accept that. In fact, you can sometimes make your own modifications and homemade upgrades to transform an otherwise inexpensive, frustrating tool into something much more suited to the task. Take this Harbor Freight metal brake, for example. It bends sheet metal, but it was an absolute pain in the backside if you had more than one identical bend to make, because the flat bar just laid on top, where you had to manually align and secure it with C-clamps for each individual bend. It was very easy to misalign, and that can ruin your project. So we modified it. This version has a large platform to lay the metal on, with adjustable fences and an auto-aligning bar to keep everything square and accurate. The clamping mechanism is now integrated into the bar, and the bar is spring-loaded for quicker operation. The whole thing is also adjustable for different thicknesses of materials. In this video, I'll show you the clever way that we made these modifications, which will hopefully inspire you as you work with other frustrating tools that you may be able to improve with your own ideas. Then, at the end of this short video, I'll show you the super cool project we used this on. First, the loose flat bar is held in place with some clamps. This is roughly aligned so the brake can fold upward unobstructed. The whole thing is then attached to a plywood panel. Here, the fence on my drill press is used just to align the edge of the tool to the edge of the plywood. 1/4-inch holes are now drilled at each end, passing all the way through the flat bar, through the steel body of the tool beneath it, and through the plywood panel. I recommend some cutting fluid or light machine oil so you don't dull your bit on all that steel. Now the clamps and the loose flat bar are removed, and a stepped bit is used to enlarge the holes in the main body of the tool. I've purchased some springs at a hardware store, the inner diameter of which are a little bit larger than 1/4 inch. So these two holes must be enlarged to match the outer diameter of those springs, so they'll just drop right through. Mark the position of the tool on the plywood, then temporarily remove it. Now flip the panel over and use a Forstner bit to counterbore the underside of the panel at the points where the drill bit passed through. These two counterbore holes are for the heads of 2 carriage bolts, one passing through each hole from the underside. On the top goes a washer, then a 1/4 inch threaded coupling, which is essentially a long hex bolt. You can find these in pretty much any hardware store. They usually keep them next to the threaded rod, or some people call it all thread. We're using them as spacers. Next, the springs, which are about 1 inch long themselves, are placed on top of these spacers, followed by the body of the tool, with the springs passing through those enlarged holes just as we planned. The tool may be reattached now to the plywood base with its screws. The carriage bolts are now trimmed off just above the springs. The 1/4 inch holes in the flat bar must be enlarged so that the position will be adjustable. This can be done with a file. Try not to make the hole much wider in diameter. You just want it oblong in shape, like a short slot. About 3/8 of an inch total length should be pretty much enough. As you can see here, this will allow the flat bar to move forward and back, and that helps the jig accommodate thicker or thinner materials. With the springs in place, the flat bar can be reinstalled and secured with washers and wing nuts. Here we're making a plywood platform supported by strips of wood to raise that platform up even with the steel body of the tool beneath the flat bar. You'll notice there are 2 wood fences on top of this platform. Note how they're positioned on the inside of the wing nuts. These slide in shallow grooves that were cut with a table saw dado set, or you could use a router, and they make the fences adjustable. It's difficult to see here, but the ends of those fences are also slightly notched. This will allow them to pass over the body of the tool even after they're fit into their slots. Here the fences are merely taped into their slots to hold them temporarily. The center of each slot has been marked at 2 locations on the underside, and the same Forstner bit as before is used to counterbore for more carriage bolt heads. Then a 1/4 inch bit goes through the center and finishes each hole all the way through the wood strip beneath. Again, each slot and strip contains 2 of these counterbored holes. Next, the strips are removed from their slots, and the same 1/4 inch bit is used to widen each hole to create short slots. Just as with the steel flat bar earlier, a file can help finish the job. Short 1/4-inch carriage bolts with washers and wing nuts hold them in place in the grooves. Then the platform is affixed to its support with screws. When the flat bar is loosened to insert a sheet of metal beneath it, the ends of the fences provide a reference so it remains aligned when you tighten the bar back down again. These fences have to be adjustable because the bar itself must be adjusted forward and back depending on the thickness of the material you wish to bend. The machine only has to be calibrated when you change materials. Then it will make bend after bend quickly, easily, and accurately. That was important to us recently as we built a staircase that featured white oak treads with copper risers. Each copper riser included a sheet of plywood for the substrate that was clad in heavy gauge copper flashing. The end of each piece of copper required 2 bends, which were laid out with a double marking gauge. This is the same type of gauge that's used to lay out mortises for woodworking. The modified brake made quick work of these bends, creating a J shape on the end of the copper sheet, which slipped over the end of the plywood. This process was efficient and repeatable on every step in the staircase. I'm holding back the video on the full staircase build for a while because I'm waiting to see how the copper tarnishes over time and how much maintenance is required to keep it looking nice. Then I'll do a full reveal on what turned out to be a really cool and unique project. Want to see something else really cool? It's just a couple of cuts. Your ears will be fine, right? They will be if you have your IsoTunes Bluetooth earbuds in, because you'd already have your ANSI certified hearing protection on because you're listening to your favorite music and podcasts. And you're supporting a small family business at the same time. Please use the link below this video to learn more and to show them you support what we do as well.